Good morning, everyone. I'm Pachara Thananurak from Division of Animal Science, Faculty of Agricultural Technology, Rajamangala University Technology, Thanyaburi, Thailand. Today, I would like to talk about improving the technique post-stall quality and fertility ability of chicken semen cryopreservation. First, I will talk about how the importance of semen cryopreservation in poultry is an effective method for the long-term storage or prevents value for the optimization of male genetic potential. However, unlike other species, avian reproductive physiology is so unique. The quality and fertility of post-stall chicken are far lower than the fresh semen, and more frequent artificial insemination is needed for improved fertility. For that reason, a suitable extender and cryopreservation method are crucial for the post-stall sperm quality and fertility, since it has stimulated research interest in developing the proper extender and technique for the frozen semen storage. One of the importance of the cryopreservation technique have been developed. They can be used to efficiently preserve these vulnerable genetics and enable us to share these genetics to a remote area and the countryside. Also, the development of the successful simple protocol for the cryopreserved chicken semen with least sperm number per dose of the AI and the fertility outcome in the approaching to the result of AI with fresh semen or the natural mating. They may sufficiently advance to making application to commercial site breeding program or the preservation of genetic resources. The freezing and thawing of the sperm is a complicated process that are able to include several forms and cellular injury. This damage has been attributed on multi-chain intercellular ice crystal, cold shock, reactive oxygen species, with the reduced permeability membrane characteristic of the motility, viability, and fertility ability of sperm after AI. However, the degree of the damage also depends on the composition of the extender and type of the cryoprotectant. For this reason, the cryoprotectants are included in the freezing extender, and in order to reduce the deleterious effect of freezing and thawing process. Moreover, a suitable extender is crucial for the post-stall sperm mature fertility ability, since it has stimulated research interest in developing a proper diluent and the technique for the frozen semen storage. There are significant extender release on the sperm morphology and the short-term liquid semen storage. Principally, an ideal extender should be able to provide energy for metabolism of the sperm cell, maintain pH and osmolarity, and it should be capable of the sustaining of the viability as well as the functionality of the cells. Composition of extender differ to one another depend on the physical property with the change sequentially and relatively the minor change in the temperature. Not only that, but depend on the interaction between solute or solute to solvent. Semen diluents are based on the chemical composition of the animal semen. For the cryoprotectants such as dimethylacetaminide, dimethylformamide, and methylacetamide, have been analyzed as the alternative of glycerol or cryopreserved chicken semen. In our previous research, proved TNC extender to be a suitable media when used for cryopreservation in Thai native chicken semen. Moreover, it can be applied to the various chicken breeds since it can maintain luster and its fertility potential. Following freezing and thawing process, it is believed that the osmotic pressure, pH load, and citrulline in the TNC extender contribute to the superiority of the cryopreservation of the roasted spermatozoa. The success of freezing and thawing procedure is highly variable depending on the genetic line, animal conditions, and mostly the know-how of the each lab. This led to the development of many different methods. However, these multiple protocols are not routinely used in the poultry breeding. They still need to be standardized and to prove their efficient to obtain high quality of post-thaw sperm. In Thailand, our team have carried on chicken semen cryopreservation research under simple method of freezing from 2007 until now. Nowadays, simple freezing styrofoam box has been used in the chicken semen freezing in our lab, and its method yield fertility rate around 80 to 93% after AI, with 400 million sperm per dose per 1 a week. For the objective of this study, the aim of this study was to evaluate the effect of 6 and 9% of dimethylformamide in TNC extender for the freezing chicken semen, as well as fertility ability after AI, with optimal sperm number of the cryopreserved semen feasible for using in commercial chicken production. About the material and method. For the animal that we used in this study, about male of Thai native breed, they were housed in the individual case under natural photoperiods and fed with a commercial diet. Female used for AI. Hen day production was approximately 85%. They were exposed to natural and received the laying hen diet supplement with calcium. The semen collection, cryopreservation, and thawing. Semen were routinely collected twice a week. Semen was collected according to the technique initially described by dorsal abdominal massage method. Care was taken to avoid the semen contamination with coagulant product. After collect, semen samples were evaluated under a microscope and were selected on the basis of the following criteria: sperm viability up to 90% and the sperm motility score up to 4 score was used for cryopreservation. The pooled semen samples were diluted with TNC extender. For the experiment 1, the effect of 6 and 9% of DMF in TNC extender for freezing chicken semen. The semen were collected and pooled and randomly divided into 2 groups. 2 treatments were done as follows. Treatment 1. The semen sample diluted with TNC extender with 6 DMF, and treatment 2. The semen sample were diluted in the TNC extender with 9 DMF were added. Semen was frozen with simple freezing method using nitrogen vapor with the styrofoam box we will see in this picture. This evaluation of semen quality is both towards include the use of motion sperm parameter, viability, chromosome integrity, and mitochondrial function. About the different dose on fertility ability. The effect of sperm number of cryopreserved semen on fertility was also tested. All hens were inseminated once a week with frozen whole semen. Sperm insemination volume with each treatment was 400 million and 200 million sperm per hen. Eggs were collected on day 2 to 8 after each insemination. The fertilization rate were determined by carrier egg on day 7 after start of incubation. Fertility was determined by carrier egg on the day 7 of incubation. 6 replication of the fertility in each test were performed. Hens were artificial insemination once every 14 days. We will see about the result. The table 1, the effect of 6 and 9% of DMF in TNC extender for freezing chicken on sperm quality. The results show that the motion sperm percentage of chromosome integrity and active mitochondria were significantly higher in TNC extender with 6 DMF. The thawing semen of each concentration of DMF was inseminated to determine the fertility rate. The highest fertility rate was found in TNC extender with 6% DMF. On the table 2, we will see the effect of different doses on the fertility ability of frozen thaw chicken sperm. When inseminated female with different doses of sperm, 200 and 400 million per female, the fertility rate was not significantly different among these men. We will go through the summary and conclusion. Semen cryopreservation in potty is an effective method for the long-term storage of the prevent value for the optimize of the male genetic potential. We recommend the presence of 6% DMF concentration in the freezing extender to be an cryoprotectant in order to increase chicken semen feasibility. In addition, we proved that the TNC extender is a suitable media for cryopreservation in Thai native chicken semen. Moreover, it can be applied to various chicken breeds since it can maintain roster semen and its fertility potential following the freezing and post-freezing and thawing process. Finally, the successively sample freezing box for chicken semen cryopreservation was developed with suitable for the storage of the genetic for commercial and AI dose for the use of chicken semen cryopreservation. The results are encouraging and be able to prove the usefulness of cryopreserved semen storage and suitable for medium-sized commercial chicken farm. The AI using chicken cryopreservation semen under the present technique performed in 7-day interval with the 200 million total number sperm per hen. The fertility outcome is approaching to the result of the AI with fresh semen or natural mating and applicable to the commercial breeding program.